Hey guys, right here, back at it with another video. I was watching some service from PCA Nakuru West suburb. So from the previous video, we saw the concept of a troid amplifier, reactor amplifier. So 3 sets of coils. 2 of the coils are harvesting. One coil is pumping electromagnetic field into the troid, and then the other 2 wires are harvesting that magnetic field, converting it back to current and pumping it back to the first wire. So the circuit looks like this. There's a voltage source, the current comes here. These are an induction coil through for better results, it's through a troid. There's a ferromagnet at the center. So once it comes out of the coil, it comes out through this wire, comes like this. And then the second coil is coming, set of wires like this through the troid again, the same troid, and then coming out having a diode into this wire. This diode is to prevent flow from this, so flow is only in one direction through the troid. This is a replica of this. It's just for 2 optimization. So once it harvests power from this troid, it pumps that power back into the wire. So in this wire, the power is P1 plus P2 plus P3. So this is a better circuit with a diode in each stage. There's a diode to prevent flow back into the troid. There's a diode to prevent the flow from this circuit, from this and this, going into this wire. So the flow is coming out of this wire. Any generated wire is flowing back into the, and then it's forming a loop, coming out, going back into the loop. So this is a replica of this. So yeah, and then this was now from using control concept. You use it as a feedback. So the inductor is at the front, and then the input is coming back to the back. Hope you get it. With the diode at this stage, there should be a diode at this stage here and here. So it comes, feeds, flows like this, comes out. There's no from this side, and here there's a diode here. So from that concept, I had this Kenya Power idea. Now using transformers. These are transformer. Each box represents a transformer. So the power on this side is supposed to be equal to the power on this side. So, and power equals to number of turns times current. So number of turns in 1 times current 1 should equal to number of turns in turn 2 and current in the same turn. So the circuit is coming like this. This is an induction coil, obviously. This is a transformer, and then coming out. And then from the induction coil, there's an output and an input. So the output is coming like this into another induction coil. This is another transformer, and then coming out like this to another induction coil, another transformer coming out like this, and then completing the circuit. And then from here, you take the output from this transformer, feed it back into this transformer, and the output of this transformer feeding it back into this. So this and this line are in series, this and this line are in series. It's flowing like this, coil coming out, coil coming out. This is like this, coil coming out, coil joining this. So this is when it needs in series transformers. So you can pause the video and check. So N1 I1, N2 I2, N3 I3, N4 I4 this side, N5 I5 this side, N6 I6 this side. So these are the results, N1 I2, and their powers, respective powers, N5 I5, N6 I6, and the respective powers. But eventually you find that the output will have now 9 kilowatts, 6 amps, 1500 volts, and we are starting with 2 kilowatts, 1000 tons, 4 amps, 500 volts. So That's when it's in series. In parallel, this is a transformer, this is a transformer, this is a transformer, this is a transformer. So the output is coming into this transformer. The induction coil is like this, coming out, going back, and then from this joint coming again. It's supposed to mesh into this transformer straight into this coil, coming out like this. But again, this transformer has an output, so the input is like this, and then coming out, fed back, because this is the output and now this is the input. It's fed back into here, and this comes out, fed into this side. Eventually these lines should look like this from this point to just remove this line. So we have this and we remove this. So this point, you get this when you put your joint here and a joint here, this will be parallel. So see if there's a, so let it just come straight and then coming out. So from there, output from this transformer, it's interchanged. You join it with this line coming into the input, and then output from this transformer coming to the input of this side. So your VOut will be here. N1 I1 is on this side of the transformer, N2 I2 is this side of the transformer, N3 I3 this side of the transformer, N4 I4 this side of the transformer, N5 I5 this side of the transformer, N6 I6 this side of the transformer, N7 I7 this side of the transformer, and Vout N8 I8 this side of the transformer. So this is the table. We start at 1 kilowatt, 1 kilowatt, 1 kilowatt, 1 kilowatt. Here it will be N5 I5 22.2 kilowatt, 2.2 kilowatt, 5 kilowatt, 5 kilowatt. You hope you will just follow it. So for this one I didn't explain well. It will be 1 kilowatt, 2 kilowatt. I'm starting with the input of 2 kilowatts to 2 kilowatts output. For 3 it's 2 kilowatts on this side, 4 kilowatts, 2 kilowatts on this side, and then now from there there are two ways you can go with this. When this transformer, when it's a step up or when it's a step down. So for this one, it's when N5 I5 is you step up the voltage. You step up the voltage. So this is when it's a step up, this is when it's a step down. So when it's a step up, you get 4 amperes on this side and 4 amperes on this side. So there's roughly, and this is for N5 I5, N5 I5 is this one, N6 I6 is this side. So you get 2 amperes on this side, 4 amperes on this side, 2 amperes on this side, and then for N4 you have 4 amperes on this side, 2 amperes on this side. So when you have 4 amperes here and 2 amperes here, they are roughly at the difference, so they will sum up. So from the first cycle it will be 4, 2, and then they sum up, so it will be 6. From there you get, it will be amplified. I haven't done the amplification, I've just done for the initial cycle. So from there you get, now from your output on this side, since N5 I5 and N6 I6 will be different, the power on this side will be 2 kilowatts, the power side will be 2 kilowatts. But N5 I5 is 4 amps, and N3 I3, this one, is 2 amps. Remember this wire is in series, so 2 amps here, 4 amps here. It will become, what will return back will be 6 amps, 2 plus 4, 6 amps. So when now this becomes 6 amps, this will change. I haven't done that much, but it will be amplifying. Hope you've gotten the basic concept. So, and then from there is 500 volts on this wire, yes, and 1000 volts here. So the voltages, power sums up whether in parallel or in series. So it will be 1500 volts plus 6 amps. which becomes 9 kilowatts. That will be the output from here, from the single cycle. So obviously with more cycles, more amplification until it maxes out. I'm not sure where it will max out. So from there you can now come to another form of connection. Now this is your input, and then come into your output. So this transformer, get the output, connect it to a transformer. So this wire is coming like this into this transformer, into this inductor, coming out, coming here into an inductor, coming out like this into an inductor, coming out into an inductor, coming out into this inductor, completing the circuit. So this is the one wire, you get. And then now this is your input, induction here, coming out like this. And then from this transformer, from this coil, it comes out into this coil, comes out to this coil, comes this. So this is the wire, this is one wire. And then obviously the same with this one, an induction here, coming out, an induction here, coming out, an induction here, coming out. Yeah, so you get it. I haven't done its math, we'll try to crunch it. So I'm trying to plot a better form of reactor into Autodesk Inventor. The main concept will be from this trade. Obviously when you get a trade like this and have a magnetic field going round, from the principle of your magnetic field will be going round like this, round the troid. So current is flowing inwards. So when you connect these troids, several of them, through just the troids, not the wires. So you imagine there's another troid at the back, another troid at the back connected. There will be current flowing through the troids. So these are troid forming its magnetic fields to another troid, to another troid, to another troid. So the magnetic fields are flowing inwards. Wait. The magnetic field is flowing around like this into the troid. So when this troid is connected to this troid, current will flow. You imagine these troids are connected together, the current should flow around it. You'll see it once I plot it. So yeah, that's it. Please do share, like and subscribe. Thank you.